Lesson 13.12, our last lesson in this exponential section, says plotting points and graphing exponential functions, which we already did, but this time it's just giving you an equation, not a table. So you can use Desmos, you can use your graphing calculator, you can make a table on your own pretty quick, and I'm probably going to use that option and then show you on the calculator after. So in this function, I see to the x power. That's my normal function. Then I see a minus 8 after that. That tells me that my asymptote, my parent function, moved down 8. So I'm going to have an asymptote, and I think they make you answer that first, at y equals negative 8. And I'm going to abbreviate that with HA, horizontal asymptote. And it's got to be y equals a number. So then from there, I'm going to make a table. I'm going to just start with 0. If x were 0, that would say 2 to the 0 power minus 8. Anything to the 0 power is 1. 1 minus 8 would be negative 7. So there should be a point at 0, negative 7. That would be the y-intercept. Let's try 1. So if I had 2 to the first power minus 8, that would be 2 minus 8, which is negative 6. So there's a point at 1, negative 6. Let's try 2. Plug in x is 2, that's 2 squared minus 8. Well, 2 squared is 4. 4 minus 8 would be negative 4. I'm starting to jump a little bit faster. If I plugged in 3, that would be 2 cubed minus 8. 2 times 2 is 4 times 2 is 8 minus 8 is 0. So 3, 0. That's actually enough points to make my graph because it just wants 4. And that would be it on that one. And number 2 is a little harder because we do have a fractional base, but I'm going to show you how to do it by hand. Also, I'll show you how to graph this one real quick too. Here it is put in, 2 to the x power minus 8. You can go to graph and see it. It looks just like mine. You can go second graph and it pulls up a table, and you just need points that are going to fit. So it can't be any of these with a decimal. You're going to have the 0, negative 7 like we did, the 1, negative 6, the 2, negative 4, the 3, 0. You could have 4, 8. And then 24 gets too big. So you only had 5 options to choose from anyways. All right, on number 2, I see the plus 1 on the end. So that means my asymptote is going to be at positive 1. So the equation is y equals 1, which would be here. Since this is 0.5, that's less than 1, it should be a decay problem. Since the base is smaller than 1, here the base was bigger than 1, that made it the growth. But so if I made a table, it's a little bit trickier to figure out what to plug in. If I plug in 0, 0 minus 5 is negative 5. I'll put it in here. So 0 minus 5 is my power. So then that becomes negative 5. Do you remember that a negative power does not make this negative? It flips this and then makes it a positive power. So it's actually 2 to the 5th plus 1. Well, 2 times itself 5 times is actually 32. 32 plus 1 would be 33. Way too big. So let's actually work backwards. Let's do... let's actually do 5. So if x is 5, right here, 5 minus 5 is 0. Anything to the 0 power is 1. And then 1 plus 1 makes 2. So there would be a point of 5, 2. Okay, if I keep going, let's do 6. 6 minus 5 is 1. 1/2 to the first power is 1/2, so that's 0.5. That's not going to help us on there, but that goes down. So let's go backwards. Let's go to 4. 4 minus 5 is negative 1. 1/2 to the negative first power is going to flip this and be 2 to the first power plus 1. That's 2 plus 1 is 3. So there's a point at 4, 3. I should be able to plug in 3. 3 minus 5 is negative 2. 1/2 to the negative second power is going to change it to 2 squared plus 1. That's 5. Okay, so it's going to be doing this. And that's your graph. But again, you could put it in. I would do parentheses, you could do the fraction, you could do decimal 0.5 to the x minus 5 power. Again, if your calculator does not float this up, you're going to put parentheses around that so it knows it's all of the power. Go down to get the +1, hit graph, and you can see it right there. Go to table. We had points, we didn't have 2, 9 yet. We had the 3, 5, the 4, 3, the 5, 2, and then we said the 6, 1.5, but Delta Math won't let you graph that. You can also see where they start getting really, really, really small, but yet it's never going to get to 1 other than your calculator's just rounding. It only has so much room for digits, and so that's why it looks like it goes to y is 1, but it really doesn't.